This lesson is on linear programming. And just to go over those definitions as a review, it's a mathematical technique used to determine which solutions in the feasible region result in the optimal solution of an objective function. Many real-life problems involve optimization or finding the maximum or minimum value of some quantity. So even in our world, that's what marketing is. We want to, if you're running a business, make the most amount of money and have the least amount of expenses. So in order to find out where this perfect solution is, this perfect happy medium, linear programming is our best friend. Linear programming has 3 parts. Number 1, restrictions. This tells you what type of numbers you'll be dealing with. Real, integer, whole. So for example, if we are trying to optimize our time can be measured as decimals or fractions, but it can't be negative. So we're dealing with we're dealing with real numbers that are 0 and above. So all are positive real numbers. So that is a restriction. A constraint are your lines that create the area to be optimized. So we get that solution region. And then objective quantity is the equation being tested for our minimum or our maximum values. So here are the steps to solving. First, you want to graph all the constraint lines to find which region of the graph solves all constraints and shade that region in. We'll want to solve to find all of the vertices around the shaded region, so all of those corners. And then we'll test every vertex, all those corners, into the objective quantity, or that objective function, to find the maximum and the minimum value. Here's our first example. We have a butcher shop that makes hamburger patties and sausages. Hamburger patties sell for $2 and sausages sell for $1.50. The butcher noticed that they always sell at least 250 sausages and hamburger patties together, but never more than 100 hamburger patties or 300 sausages. What is a maximum profit that can be made? So that's what I want to do. I want to maximize my profit. And I notice that in my example, this first point deals with money. This is where I'm going to get my objective function from. The second point deals with all of my constraints. So this right here. So first off, we want to label who will X be and who will Y be. So I'm going to go ahead and put that X can be burgers and Y can represent sausage. Okay, I can't sell negative burgers or negative sausages, so that's why my graph, I'm only in quadrant 1. And I'm going to create some linear inequalities. So the first one says that together, the butcher always sells at least 250 sausages and hamburger patties. So I can represent that as X plus Y, burgers and sausages, will be over or equal to 250. But never more than 100 hamburgers, so X will be less than or equal to 100. And Y will be less than or equal to 300. So never more than 300 sausages. I'm going to graph those 3 inequalities. What I notice about my first graph is that it's not in y equals mx plus b format, so I'm going to move the x over to get y by itself. There we go. Okay, I got my 3 inequalities, and I want to make my graph so that I can fit 250, 100, and 300 on there. So if I use, let's see, if I go up by 25, that should work. Okay. So my first graph, I'm going to start at 250, and my slope is negative x. So that's going, if I want to add a fraction, I can just put in 1 over 1 as my placeholders. So down 1, right 1. Down 1, right 1. Perfect, and then that can be a solid line. I can test a point to see where my values are at. I'm going to test that point 0 and 0. So I'll plug in 0 for y, 0 for x. And when I simplify, I get that 0 is greater than 250, which is not true. So then all my answers will be above. All right, I'll graph the next constraint that x is less than 100. So on my x-axis, I'll find 100. And I'm just going to draw that line going up and down. It's a solid line. And all my x values have to be less than 100. So I'm going to be to the left of that line. And if you want, you can check a point like 0 and 0 and find that 0 is less than 100. So that's where my answers are. And my y value is less than 300. So I find 300 on the y-axis, draw the line across, and I have to be less than, so I am underneath. And I find there is a shared region for all 3 constraints. So I'm going to go ahead and I'm going to dot that section. And I'm dotting because we can only sell whole amounts of hamburgers and sausages. We cannot sell half or 3/4. So I'm dotting to show only whole is allowed. Okay, so there I have my solution region. I'm going to go ahead and create my objective function. So I want to maximize a profit that deals with money. And if a hamburger patty sells for $2, I can represent that as 2x. And a sausage sells for $1.50, so I can represent that as $1.50y. And that is going to equal my profit. I'm then going to look at my graph, and I'm going to find all my vertices, all the corners. So this one here is the point 100 and 150. This point here is the point 100 and 300. This point here is the point 0 and 300. And this one here is 0 and 250. So you're going to plug those 4 points into your objective function. I'll just label them. We'll go 1, 2, 3, 4. So I'm going to go ahead and I'm going to plug 1 into my objective function. So instead of x, I replace it with 0. Instead of y, I replace it with 300. And if you were to plug that into a calculator, you are going to get 450. And I try point 2. X value is still 0. The y value is 250, which is 325, so that's less. Point 3, my x value is 100. My y value is 300. And I get 650. For 4, x value is 100. Y value is 150. And that gives me 200 plus 225. And that's 425. So point value 3 gave me the highest profit. So what is the maximum profit that can be made if you sold 200 hamburgers and 300 hot dogs? Okay, well done. I'm going to stop the video there, and you're going to have to watch the second video to catch the next example.